20 minutes and one at L minus 45 minutes. We'll bring the facilities up, check that with the range, then bring the vehicle power up, do internal transfer within the systems on the Taurus, as well as checking with systems on the range. T-minus 55 minutes, we'll go into what we call a hot count. It's basically the terminal phase of the count. And you'll hear the call for the spacecraft to go internal at T-minus 12 minutes. That switching will start, and we'll be able to confirm that at T-minus 8 minutes. Our T0 is 1:51 and 30 seconds, with potentially a second opportunity 4 minutes later. Back to you, George.
All right, thank you, Chuck. And now to John Brunschweiler from Orbital Sciences Corporation, the Taurus Program Manager. John?
Thank you, George. Yes, I first have to say, along with Chuck and the whole team, that I'm honored and privileged to be here today. This is a historic mission and a first, as Chuck mentioned, for many of us. A first for Taurus XL. This is the first time that we are launching a spacecraft for NASA as the primary customer. And being our 8th Taurus launch, it's quite exciting to now be part of this team. Now, to get here, let me talk a little bit about what had transpired in addition to actually making the rocket. We had to go through a certification process with NASA that they conducted over the last, well, it's been a little more than 2 years. And this process is where NASA investigates and assesses the design of the Taurus vehicle, our components, the processes, to ensure that it's the lowest risk possible for these valuable payloads like OCO that we're going to launch today. And completing that certification was a large milestone for us, and now we join actually an elite club of launch vehicles like the Delta II, Atlas V, and our sibling launch vehicle, the Pegasus. So we certainly are looking forward to that, and as a culmination of hard work. We've had over 800 people working on the OCO mission at Orbital, and we're only 13 minutes of this whole day. And I'm sure when Dr. Crisp comes on and talks a little bit later, we have such a minuscule part of this, and the big part is to come early tomorrow morning. Now, with the certification complete, we actually did have to build the launch vehicle, and I can't top Chuck's video, and I hope you were watching closely. I'll try to summarize kind of what we do over the last 2 years in building the vehicle. We have our design engineers and analysts in 2 locations, in Dulles, Virginia, at Orbital's headquarters, and also in Chandler, Arizona. And we work the design, get the hardware ordered, and it really culminates in the hardware arriving here at Vandenberg Air Force Base. And as you saw in the assembly, we really have 3 major components that make up the Taurus vehicle. The Stage 0, which is an enormous 60-ton solid rocket motor. The upper 3 stages, which we call the upper stack for maybe obvious reasons. And then we have something called the encapsulated cargo element, and this is probably the most important piece. This is really, it's 2 fairing halves of our vehicle, as well as a base structure. And what we do with that is encapsulate the OCO spacecraft in a cocoon-like, and we keep it clean, we keep it the temperature regulated. We actually have a nitrogen purge, which keeps very low humidity. No type of contaminants can get to the instrument. It's a very sensitive instrument, and we need to keep it safe until we get to orbit. So as you saw in the video, Stage 0 gets down to the pad. We use a crane to lift it onto our austere launch site, followed by the upper stack, which come down and we do our final tests underneath a tent with rattlesnakes, frogs, and the like. Now the payload, which is kept clean in another clean room facility, our fairings are cleaned in our factory and shipped directly to this clean facility where we encapsulate the OCO spacecraft and bring it down to that tent. Again, keeping it away from all the critters and grime and whatnot that you'd find out at this site. So once we do our final test horizontally and mate the ECE, which is the nose of the vehicle, to our upper stack, we then perform that lift, which you saw, and that's about 10 days out. We'll do that lift. certainly within that last week. Now, commenting on the launch window, I know some people say, well, gee whiz, you know, it's at 1:51 a.m. Why do you have to go that time? Well, one of the things that's special about this spacecraft is it's going to join up with, as mentioned, a number of other Earth-observing spacecraft known as the A-Train. This is the afternoon constellation, so it tries to pass the same spot on the Earth each time of the day, and we can go into orbit dynamics maybe at another time, but suffice it to say, it's important that all these spacecraft observe the same point on Earth at about the same time to get as best science as possible. So we don't pick the window, the science does. And to do that precisely, we only have about 4 minutes and 30 seconds to do this. So if you choose to, depending on where you are in the world, if you choose to get up in the middle of the night, you don't have to wait very long. We're either going to go in 4 minutes and 30 seconds or we'll try again tomorrow. Now, during the flight, of course, stage 0 ignites and burns for about 90 seconds, drops into the ocean once it's depleted, followed by stage 1. And then about 3 minutes into the flight, we're out of the atmosphere. And this cocoon, this fairing, comes off and exposes the OCO spacecraft. That's during our stage 2 burn. And then by 10 minutes later, we're on orbit. We're about 624 kilometers above the Earth. And 2 minutes after that, once we do a precise pointing maneuver, we separate the OCO spacecraft. And the OCO spacecraft will come alive and become a historic observatory. And within the hour, I know that we'll be getting telemetry back at Vandenberg at the Launch Center, as well as the Mission Ops Center back in Dulles, Virginia. And I'm sure that we'll hear cheers and celebrations from the spacecraft as well as the launch vehicle folks. And it's going to be a good mission. Coming in we had a morning Air Force launch readiness review, and coming over here we saw a rainbow over the horizon. So it should be a good day. Thank you. Back to you, George.
Thank you, John. And now to Dr. Ralph Basilio from the Jet Propulsion Laboratory. He is the OCO Deputy Project Manager and will serve as the Spacecraft Mission Director tonight on console. Ralph?
Thank you very much, George. Good morning, everyone. The three major partners on the Orbiting Carbon Observatory, or OCO mission, that's NASA's Jet Propulsion Laboratory, Orbital Sciences, and Hamilton Sundstrand, are not only pleased, but it's sincerely excited about this important scientific mission. This is a first mission that will provide the first complete picture of human and natural sources and sinks of carbon dioxide emissions